All right. In part of these meninges, we have a subdural space with the dura, okay, which helps separate the arachnoid from the dura. So even though we've got those three tissue wrappings, it's now seeming like for around the brain, we've got some area that will help separate the dura from the arachnoid from the pia. There's a couple of reasons why we got to have that, okay? And one big one is the cerebrospinal fluid that has to flow. We got to have space for that cerebrospinal fluid to wash over the tissues, and we've got to make sure we get a blood flow. Okay? So this is a really cool structure. I know y'all get tired of me saying it. I need another term. Somebody give me another term besides cool. What's some more? That's showing my age. What's a more hip term?
Fascinating.
Huh?
Fascinating.
Fascinating. Okay. It's really fascinating. All right. So if we look at the structure, once again, here's my delicate tissue, and it is delicate. Okay. Here's the bone that it's encased in. As I begin to look at all of the protection that it's going to find, they're trying to show me some of my arachnoid mata, which is very well vascularized. They're trying to represent vascularization. We see that the tissue itself, very well vascularized. They're trying to represent the tough outer covering, but something else that they're trying to show us in this picture. Cauliflower. All right? This right here, part of being arachnoid mata, it's forming what is called a granulation. And it literally looks like little pieces of cauliflower protruding outwards. Okay, does everybody kind of notice those? Because we're going to talk about those. This is that pia mater, the one that kind of runs with the foldings of the tissue. But these little cauliflowers serve a very important function. Okay, so just keep that in mind. We'll have another picture again. But they are going to be a part of CSF and the washing over, and because one of the things about CSF, okay, with cerebrospinal fluid is not stagnant, okay? We are constantly producing it, and it's constantly being used. So therefore, we have to have a way to dispose of materials and continue to produce it. We do that because in the structure, in the brain, we have ventricles. Now, let's go back a second, or do I have a picture? Yes, I do. Okay, we have ventricles. So, let's take a peek at the next picture so that you can understand when we say the lateral ventricles, third ventricle, fourth ventricle, cerebral aqueduct, that sort of thing. When you're looking at the lateral view, They're trying to represent it with the shadowing that's present. Note, we've got these exist on each half, okay? So if you're looking at this lateral view, over here, anterior view, we've got big one, big one. Looks like they're to the outer sides of the median. So these are lateral. Does that make sense? So these would be my lateral ventricles. Lateral ventricles, because I have two of them, one on each side, okay? They are considered the first and the second ventricles. Is everybody following me? The first and the second ventricles, they're simply termed lateral because you've got one on each side, all right? The first and the second ventricle need to meet the third ventricle. The third ventricle needs to meet the fourth. So, I have first, second ventricle that will meet the third ventricle by a foramen, the interventricular foramen. The third ventricle will meet the fourth by way of an aqueduct, a waterway. Does that make sense? So now, if I think about cerebrospinal fluid, all right? First, second ventricle. It formed the arc that we saw. It meets the third by way of the interventricular foramen. The third meets the fourth because of an aqueduct, the cerebral aqueduct, a waterway, okay? And for each ventricle, on either the floor of it or the wall, it contains, oh, spelling error, sorry, that's my mistake, choroid, C-H-O. My mistake. Plexus. At this point, what does the term plexus tell us? Does anyone remember what plexus meant? It's a bundle of something. We learned about it for our cervical plexus, brachial plexus, lumbar plexus. Does everybody remember those? Now, for it being choroid plexus. It is a mass of blood capillaries. How many of you think about blood flow? Where does blood get to exchange anything? At what part of a vessel structure does blood get to make any type of exchange with tissues?
Is it capillaries or?
The capillaries are the only part.
Okay.
It is not. It is not at the level of the larger arteries or veins. A lot of times when people think about blood flow, they think of blood flow. I always feel so weird carrying these. A lot of times when people think of blood flow, they simply think of these. What are y'all's thoughts? Do you think stuff gets exchanged at these levels with tissues? No. These have to go meet their region of the body, and as they do, they continue branching, 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 to the point they become a capillary. Those areas are microscopic. We can't see them. They're small. They're one cell layer thick. It is the only point at which there can be exchange of fluids with tissues of the body. So now, in the brain, I'm going to have these areas, these ventricles, that are going to contain masses of blood capillaries. And I'm going to have a blood flow to these areas. And I will now have access to fluids. And what is my CSF? Fluid. Okay? So, we're going to see we have a type of neuroglia. Do you remember that from chapter 12? Do you remember glial cells? What type of cell are they? What do glial cells do? They support. They are support cells to neurons. Now, I've got cells, I've got capillaries. I now have the arrangement to make cerebrospinal fluid. So, in these ventricles, the lateral, which is going to meet the third, which is going to meet the fourth, they are lined with the cells I need to make cerebrospinal fluid that is going to be able to make its way over all this tissue with all these neuron cells. Okay, I don't know if you guys know this, but the cells of the brain, they cannot in any way renew. What you get is what you got, okay? And my cerebrospinal fluid can wash over them, bring them nutrients, and take away waste. Where does the waste go? I love that question. The cauliflower,